In previous videos, we created the ResQ DIY Search and Rescue project. Today, we'll take that project through to make a new printed circuit board, assemble it, put the thing together, get it into the field, and test it out. In the previous videos, we've used fritzing for our PCB design. Well, I decided it's time for me to learn KiCad and just bite the bullet and figure it out. I was able to lay everything out with a new schematic, new board layout, and it went really easy. I just followed the YouTube tutorials, lots of information available online, and really had no troubles routing a new board. Came out pretty good. I did end up doing another revision to this later on, but it worked out really well. So off to PCBWay to order the boards. Now, same as last video, PCBWay makes this really easy to order new boards. It's super intuitive, just leave things at basically the defaults on the main page. Mine, I'm going to panelize them, but that's pretty much the only deviation from norm. Because these are really small boards, we want to panelize so we can get lots of boards, about 60 actually on a 10 board order. As always, when I order boards, I go back to different areas of the project. In this case, we're going to do the camera enclosure for the ESP32. This is a standalone module that's triggered by ResQ to take a picture using the ESP32 and camera module. Now, I had no luck finding a good enclosure that suited my needs and something that I could release with this project without running across any licensing issues. So I just designed it from the ground up in Fusion 360, the same as the other enclosures. Because they're parametric, I used the exact same files and just scaled them down, added a cutout for the SD card and the lens, and printed them out on the i3 Mega. Enclosures came out great, as always. I left it big enough so that I can put the ESP32 in with the pins installed. That way I don't have to go through the headache of removing them. All the online suppliers seem to come with them pre-installed. And this worked out really well. Good quality, good enough for this project. A few stickers on the Cricut vinyl cutter just to make this project that much more legit. Things are looking pretty good.
It's a fight against the gods.
Now for the ResQ Sentry, this is the camera module version, the stationary ground version. I wanted a new case that could be cut on the laser cutter or cut out by hand from wood or any kind of material. So here's one spinning off on the K40 laser cutter, no problem. Also for the ResQ Sentry, I wanted some way to keep this thing powered up. So if I mount one of these in, say, a game preserve to watch for poachers, well, we need some way to to keep energy flowing in so we can keep reporting out. The solar panel seemed to fit the bill. This is for trail cameras and game cams. It comes with batteries in the unit, really ruggedized, comes with just a power out wire that plugs into some kind of proprietary game camera, but we'll cut the end off, join it to our ESP32, and we are all set. And PCBWay delivered again. Wonderful packaging, no issues, and inside are these super cool new boards. I went with white solder mask this time to easily tell them apart from my V1 boards, and I really love the look of them. Super clean, really nice. They look pretty cool. I'm pretty proud of them. Now all that's left is to see how I did with my routing. This is a brand new board from the ground up in KiCad, so I don't know whether I've made any mistakes. It turns out in the end, I hadn't, so we'll go ahead and get things assembled. Wanted to shift gears yet again and go back to the camera module. We had already 3D printed a module case for the ESP32 cam, but I wanted yet again to have more options for other people out there. So I wanted something, a 2D model that could be cut out of plastic, wood, foam board, whatever, or laser cut like I have here. Well, to do that, we need the 2D model. It's easiest for me to just use this MakerCase website and then modify the files afterwards in Inkscape to just add the holes. Really easy. And a trial fit together, no issues. You can remove this blue plastic cling wrap protectant afterwards, and you have a nice water clear case that you can paint or colorize however you wish. Just super glue it together and we're all set. Now, I also wanted to test this out of wood, so we're going to try some 3mm Baltic birch next. And the results, just fantastic. I love the way this K40 laser cutter is working now with my modifications. I have another video on that being edited now with the new additions I've done, this new bed and the ammeter and stuff, but super happy with the results. We have a case. On this night, I decided to work on the Bluetooth integration. I wanted Bluetooth accessibility to the ResQ units, both for the air or the ground units. That way, if you say took the ground unit with a YAGI antenna and strapped it to the outside of a light aircraft, like a small Cessna, for example, you could monitor for hits from inside the cockpit of the aircraft over Bluetooth with your phone. That way it just makes things real simple to do live monitoring wirelessly, lots of different applications for it. And you can also use the LoRa long range radio over this same connection. The pins are broken out on the PCB, we just had to set up the radio and test it out. After some testing and programming the HC05 module to a different baud rate, sure enough, it happily barfs out the ResQ hits over Bluetooth. No issues with just a Bluetooth serial terminal app. I just downloaded a couple of them from the Play Store and no problem with them. Worked wonderful. Now you can simply unplug that Bluetooth module and plug in a LoRa long range module and get this information many kilometers away, which is really handy with the Sentry version. That way you can monitor for poachers in the game preserve from many kilometers away. Pretty cool. And of course, Sentry needed its own 3D printable plastic case, so I designed that in Fusion 360 as well. Again, just the parametric models I already had, scaled it up, printed it out on the i3 Mega, no problems. of the most fun things is getting these projects out in the wild and testing them out. So finally had a kind of miserable fall day, which is what I needed to make sure everybody stayed home. That way the hits that I could pick up with ResQ were strictly my own. So I took a spare cell phone out in the bush, took the ResQ Sentry, the handheld base unit, and did some basically a fox hunt, so to speak. I knew where the target was, but I wanted to see how well it would work in the dense wilderness as well. Everything was very wet, which would attenuate the 2.4 gigahertz as well. And sure enough, it worked surprisingly far. I couldn't pace it off in these woods easily because there's basically no straight lines on any of the paths. But overall, I worked far more distant than what I could see through this wilderness. So if there was someone there who was legitimately lost, this would definitely detect them. It also, unfortunately, will detect anyone else who happens to be in the area, but that's okay. That's something a good problem to have overall. So pretty happy with this project. I hope you've enjoyed these videos, and I hope you get to make one for yourself. I'm super tickled with it. It didn't have any success on Hackaday, not even so much as a sticker, but I had a lot of fun. It's out there, it's open, it's available for you to create one of your own. This video series, I believe, is 5 parts now, lots of information. If you'd like to support projects like these, I have my Patreon link down below. You can support me directly there or use any of my affiliate links down below. It helps me buy the project parts for these, and all my projects are released open source to the world. You're more than welcome to take any of my designs. Everything's on GitHub. So I wish you good luck in all your projects. I hope you've enjoyed this. I sure have, and looking forward to the next project now. Cheers.